Good morning and a warm welcome to this yet another webinar. Today we are going to deep dive into machine learning with EDA. EDA basically is exploratory data analysis. Okay, today we are going to deep dive into some machine learning concepts. We'll understand what machine learning is, what are the subset of machine learning, okay, what are the different types of machine learning. Then we'll be gonna learn about what is linear regression. Okay, then we will download a data set and we will perform all the statistical needs that a machine learning should have. So this is the overall agenda for today's webinar. Myself, Joel Fernandez. I am from Technia Solutions. So before that, let me tell you what is machine learning. Okay. So before that, you have to understand what is artificial intelligence. Okay. Artificial intelligence is something, it's like an application which can perform on its own without any human intervention. Okay. It is like having a intelligence which can think like a human. Okay, which can analyze the data and which can think like a human, and based on the situation it can take decisions on its own. So this is what artificial intelligence is. Coming to artificial intelligence, you should know what is machine learning. So machine learning is a subset of AI. Okay, so AI is a larger thing, and below that comes the machine learning, which will basically train the model. Okay, we train the model using machine learning, and that data is used to do predictions on it, so it will assist your AI. Okay, on below that you have something called as deep learning. Deep learning, you can call it as a subset of machine learning. Okay, giving going deeper into the data, analyzing the insightful information out of it, and making a very good prediction, increasing the accuracy. And this deep learning is inspired from the human brain. Okay, which basically uh, inspired from the human brain, where neurons take into place, like how we think, how the things are transferred from one neuron to another. So deep learning takes the inspiration from the human brain, and from where we can do the predictions out of it. Okay, we can do classification problem, prediction problem. Many things can be done using deep learning. From there you will have something called as algorithms, CNN algorithms. These are all artificial neural networks, RNN, GAN algorithm. Many algorithms are there. So this comes in the part of deep learning. Coming to data science, data science is a overall combination or acclamation of all these things. Okay, artificial intelligence, machine learning, deep learning. So it is like a culmination of all these sectors. So together forms the data science. Data science is removing the insightful driven data driven analysis from the huge data set. It can be a big data analysis, it can be a small data. Okay, taking out the insightful information from the data is called as data science. And training a machine learning model or a deep learning model which can do predictions or which can help a business to grow is basically a data science. So today we are gonna learn about machine learning in depth. Okay, we are gonna see some of the important functions that are present in data science as well as machine learning. We'll explore some of Python libraries today. We can visualize some of the data set. We will do all this comes under exploratory data analysis. Okay, so let me share my screen today. So once again, I welcome you all to this wonderful webinar where you are going to deep dive into machine learning, exploratory data analysis. Okay. So basically, as I explained you, machine learning is a model. Okay. It is a subset of artificial intelligence where a machine basically learns from the data, and from there insightful informations can be extracted, predictions can be done. Okay. Classifications can be done. Lot of things can be done using machine learning. Okay, for a machine learning to perform better, you need a huge data. Okay, without data machine learning cannot learn. Okay, so basically machine learning, when it comes to machine learning, there are different types of machine learning involved. One is supervised, unsupervised, and reinforcement learning. But today in this webinar we are going to deep dive into supervised machine learning. Supervised machine learning, in the sense, will be machine learning supervised is nothing but it will have a target as well as feature columns and a target column. So label will already be mentioned in the supervised machine learning type. Okay, from there you have another two important types in supervised machine learning. One is regression based machine learning, another is classification based machine learning. If your target column, like in the data set, you're gonna see all these things in the upcoming things. Okay, so before that, let me give a brief overall into insights into what this means. Okay, so in the regression model, you will have two important things. One is a feature, another is a target. So target is like a label. Okay, for this feature this is the label, for this feature this is a label. So if your data set is having a label, it comes under the category of supervised machine learning. Okay, so in supervised machine learning, when I talk about labels, okay, if your labels are continuous, one after the other, one after the other, like continuous data. For example, if I consider a college where student is there, their height is there, okay, their weight is there, and their ages are there. Okay, so these are all, this is a data set, and imagine that height to be the target column, age and weight to be the independent columns. Okay, so label is your height here. So height can be continuous, like one after the 121, 122, 123 centimeters. Okay, so if these values are in the continuous fashion, they fall under the category of regression based supervised machine learning. Okay, these come under the category of regression based. Followed by like another kind of machine learning, supervised machine learning type is a classification based problem. So classification, for example, if I can give an example, in a college, imagine the same example where student is there, their marks is there, and target column is placement. Placement has over or no. Okay, he was placed in a company or no. 1 for yes, 0 for no. Okay, if your classification, like if your target column or basically the label has yes or no kind of data type, okay, or 0 or 1. Okay, so these labels fall under the category of classification based supervised machine learning. So today in this webinar, okay, I will be exploring about linear regression, regression based classification problem. Sorry, regression based problem in supervised machine learning. So as I explained, okay, what is machine learning? Machine learning is nothing but it is a field of artificial intelligence that enable computers to learn and improve from the experience. Experience here is the data set that it is going to learn without being explicitly programmed. So we don't program it to, we don't write a code for a machine learning that it should go and learn something. Basically, this operates based on the statistical concepts, statistical algorithms. Okay, so based on the algorithms, your machine learning model will learn from the data set, and from that we can remove insightful information out of it. We can do predictions out of it. Okay, we can deploy the application. So a lot more things can be done out of it, but basically without being programmed, okay, it learns based on the statistical algorithms. Okay, so I'll gonna teach you what is all about in the coding session of it. Okay, it involves developing algorithms and statistical models that allow system to perform specific task effectively. Okay, so backbone of machine learning is statistics completely. Okay, the statistics which we used to learn during our PUC times or high school time is now being inculcated in the machine learning basically. And machine learning learns data from all these algorithms, from where statistics is a backbone of it. So in machine learning, not just applications involved, it not only does predictive analysis like prediction of the data, it also uh, you know applies in the computer visions also, computer vision, in natural language processing where it comes to AI. Okay, then reinforcement learning, lot of applications are involved when it comes to machine learning. So as I discussed, there are different types of machine learning. Okay, one is supervised machine learning where a model will have a label as a target column, and it is like basically two types of there. One is classification and another is forecasting. Forecasting is basically regression model. And unsupervised machine learning is like you don't have any kind of label there or target column there. All are independent features. Okay, independent columns are there. You don't have any kind of unlabeled, so labeled data. So basically unsupervised machine learning falls under the category of clustering. So based on the features or independent column, what you do is you group the data. Reinforcement learning is something like you will have a agent, okay, and he will have an environment. So based on that, agent will learn from itself, like without having a guiding force. What it will do, a agent will be thrown in an environment where based on the environment state, he will take in the state, he will take an action, and if the action is towards the goal, he will get rewards. So based on the reward system, positive and negative reward, a agent will learn. So AI usually, artificial intelligence or chat gpt, llm models, whatever it is there, okay, basically they make use of reinforcement learning techniques. So today the main topic is we are going to explore about exploratory data analysis. Okay, so what is exploratory data analysis? Basically it is like showing the insights that is hidden inside the data. Okay, understanding the patterns that are there in the data. Okay, what is the relationship among all the features? Okay, we are going to see in the practical on how we extract insights from it. But basically EDA is nothing but seeing the relationship in the data, knowing the missing or null values that are present in the data, okay, seeing the graphs, visualizing the graph, okay, many things comes in EDA. Understanding the quality, okay, cleaning the data set, making it data compatible, okay. So there are many types of techniques that are involved in exploratory data analysis, okay. So today we are going to deep dive, we'll see what are the things that we can cover. Okay, there are many libraries in the Python which includes pandas, numpy, cborn and all, from which we can easily do EDA analysis, okay. So what are the steps involved in EDA analysis? First, what we inspect the data, we see the quality of data. Once the quality of data is perfectly fine, we do data visualization. Data visualization follows, using Seaborn and Matplotlib. We are gonna plot the relationship. We are gonna see correlations involved. Correlation in the sense we are gonna see Pearson's correlation. Okay, what is the correlation between the target column and independent column? So these correlation will definitely help us to have a very good feature selection. Okay, once the correlation is completely done, what we do, feature engineering. This is the next step. So before that, before feature engineering, you should make sure that you are doing well with the correlation part. Okay, if the correlation between the two columns is positive, okay, you drop one of the column because it is not going to influence much on the machine learning model. So what you do, you choose the data or you choose the columns which are least correlated, okay, which is negatively correlated. So it is like a diverse data set where your machine learning model can learn from this diverse data set and it can make better prediction from the data that is given to it. So in this regression based machine learning, okay, we are learning first linear regression. So today we are going to discuss about linear regression itself, okay. So where we are going to explore a data set and we will create a model which will do linear regression data analysis. So what is linear regression? So you can see in the picture that you have a graph, something called as, and linear is something like a straight line, okay. So when it comes to a straight line, you should remember that equation for the straight line is y is equals to mx plus c, okay. So y is your independent column, okay, x is your dependent column, m is for slope, okay, C is your intercept. So what is intercept? What is slope? I did not understand. Sir, please explain me. Okay, I'll explain you. Okay, you must have seen here there is a x column, x axis and a y axis. Okay, so you must have seen that what x and y is. So coming to slope. Okay, slope is nothing but the slantness of your line. Okay, if your line is very too much slant, okay, like too much slant towards this side, that the slope is very high. If it is least slant, then the slope is low. And what is intercept? Intercept is a position from the zero, okay. So this is basically your intercept. If this is your line, from the bottom to above is your intercept, okay. And slope is this, how slantness your slope is. So based on this, okay, all the new data points, your machine learning model will try to draw a line which is called as a best fit line, and it should make sure that in the data set that is there around the best fit line, this line should cover all the data points that are around it, okay, so that the error can be minimized, okay. So here you can see d1, d2, d3, d4, d5 and d6 are the data points, okay. So it is going to draw a line where it is very close to all these data points, okay. So this is what linear regression best fit line is. So come on, if I give a new value that is 7, okay, so based on 7, based on the best fit line, it can tell you what is the value of it. Imagine your x to be a weight, y to be the height. If a new weight, if I assign a weight called as 70 kgs, okay, so based on the best fit line, it will draw a line and it will tell me what should be the height of the weight 70 kg. Okay, this is what a linear regression based model is. Basically, linear regression works on the statistical principle of y is equals to mx plus c. You can even call it as beta plus theta beta plus c. Okay, so there is another equation to define y is equals to mx plus c. There are multiple other equations also, but better is for your understanding, please know that y is equals to mx plus c is the equation of your linear regression line, okay. And the agenda to have this is to find out the best fit line which pass through all the data types and it is as close as all the data points so that the error can be minimized, okay. So this is the concept involved in the linear regression. So as I said, okay, linear regression is a supervised machine learning technique that models the linear relationship between a dependent variable and one of or more independent variable. Okay, so your dependent variable is your y axis here. Okay, it is dependent on all the independent variable, that is x. Okay, so what if there are multiple dependent variables? Okay, so your equation changes to something like y equal to mx1 plus c mx 2 plus c. Okay, based on the independent features that are there in the column, it draws a equation, and from all these things, okay, you will have a multiple lines. Okay, you will have a multiple lines, and from that you can make predictions out of it. So coming to line equation, as I told you, okay, line equation is y is equals to mx plus c, where m is the slope, indicates the changes, y is the intercept. Okay, slope is nothing but the slantness. Usually there is a formula for slope also, that is y2 minus y1 divided by x2 minus x1. Okay, so based on this equation you will get a slope of your best fit line. Okay, how slant your line should be, or you should make sure that the best fit line should pass through all the data points that are there. Okay, so this is what slope is. Intercept is away from zero. Okay, where what should be the length, okay, from the zero. This is what intercept is, this is what slope is. So based on m and x, you decide the best fit line, and based on the new data, that is x, okay, you make predictions and you store it, capture it in the value called as y. So coming to best fit line, okay, you have something called as cost function. Okay, so sir, what is cost function? So basically, when the model is getting trained, okay, your goal should be to minimize the errors or minimize the distance between the data point and the best fit line. Okay, and you, based on that, you should draw a very good line where the error between all the or among all the data points and the best fit line is less. Okay, this should be the target or aim of your function that you're doing. So this is how we find out cost function. What is cost function? Cost function is nothing but minimizing the errors, okay, between your best fit line and the data point. So based on that, when you train a model, you get something called as decent kind of slope. Okay, so this is also called as a gradient descent. Okay, where the objective of it is to minimize the cost or minimize the errors that are involved. So what are the techniques that are there here? Okay, basically when it comes to cost function in statistics, you have something called as R2 score, mean squared error. Okay, mean squared error is nothing but it is the difference between the predicted line and the actual line. Okay, actual value and predicted value. If you do the difference, okay, you get something called as mean squared error. Okay, and you square it, you get something called as mean square. So based on these parameters, you draw a cost function. Cost function nothing but it is like a gradient. Okay, its aim should be to reach to the global minima. Okay, minimum. Your error should be as least as possible. For a machine learning model to be more accurate, your function should be as least as possible, or error should be as least as possible. This is what gradient descent or cost function is called as. Okay, then in deep learning model you will have something called as loss function there. Okay, in machine learning you have something called as cost function. Okay, the agenda of both is simple. Okay, to minimize the error between the actual value and the predicted value, so that your model can be able to perform well on all the given data set. So this is what I was explaining about mean squared error optimization. Okay, simple as that. So mean squared error, what is mean squared error? Measures the average squared difference between the predicted and the actual value. So what happens is, when you train a model on a given data set, it will draw a best fit line. Okay, so best fit line will make sure that it will pass through all the given data points. Okay, so that when the new data set is one new data point is given, it should be able to make predictions out of it. Okay, so mean squared error is nothing but the actual, it is a difference between the actual value and the predicted value. Imagine your actual value was 0.1, predicted value was 0.3. So when you do difference among this, your error is 0.2. So your error is like little bit high. So what you do, based on this learning, next time when you draw a best fit line, so you will try to reduce the error as least as possible, so that all the best fit line should pass through all the given data points. Okay, this is the objective of the error. Okay, squared error. What you do is, in the difference between the actual and predicted line, what you do, you square the error completely you square it. Why do you square it? Okay, so imagine, like, sometimes you will have outliers in the data set, or your data set can be overfitting or underfitting. In such conditions, okay, squaring of error is essential to have a very good accuracy on your data set. That's why you make use of mean squared error. So coming to another parameter, statistical parameter that we will be using in the linear regression, that is R2 score. R2 score will basically tell you what is the accuracy of your model. Okay, so like when you do a fit of a model, and when your model is fit on the best fit line, you do predictions on the unseen data set. Okay, I'll explain you what it is. So how you split the data and all. For a simple meaning, for a simple analogy, you can understand that R2 score is nothing but it will show you how accurate your model is. Okay, suppose imagine 100% is the accuracy, where your model is able to predict complete exact data as that was in the test set data set. Okay, so if your model is able to predict has exactly has the test data set, we call this to be a 100% accuracy. But the condition of 100% accuracy is very rare, because experts, machine learning engineers, believe that it can be a condition of overfitting. Okay, so there is something called as overfitting and underfitting. So what is overfitting? Overfitting is nothing but it is your model is performing well on training data set and performing poor on testing data set. This is what overfitting is. Like, the best fit line will something go like this, curvy. So it will make sure that it is passing through all the feature data set. So it is performing good on your training data set and performing bad on testing data set. So this condition is called as overfitting. Coming to underfitting, it is performing bad on testing data set as well as training data set. So there are two types of condition which you come across when you train a model, that is overfitting and underfitting. Okay, as I explained. So if you get a accuracy of more than like more than 99 or near to 100%, this falls under the category of overfitting model, because having achieving such a high accuracy sometimes can be called as a overfitting, but in other conditions might not be true, but in the most of the cases we term it as overfitting condition. So once the regression is done, okay, what you do, you find out the coefficients and the model predictions. Okay, these are the result which you come across once the prediction is done. So now we will be deep diving into coding concept. We will see how we can do EDA over a data set, and how we can more insightful decision, and we will at last train a model and export a model to PKL format. So this is what we are going to do in the next slides. So for this practical today, okay, we will be downloading a dataset from Kaggle. Okay, if you want to download the similar dataset, you have to go to Algerian forest fire dataset Kaggle. So there is a very good dataset on Kaggle, that is Algerian forest fire. Okay, you can go to this website and you can download the dataset from here. Okay, since I have dataset already downloaded in my system, okay, I'm going to use the same ones. If you don't have the dataset, please go to Kaggle and type Algerian forest fire dataset. Okay, so I have this dataset in my system now. So basically this data set, I will explain you more about this data set. This data set has something called as date, month, year, temperature, RH is relative humidity, wind speed, rain. Okay, so this is what data set is. This is a raw data set which is not cleaned yet. Okay, so we are going to perform EDA over the data set, and we will clean the data set, make sure it becomes machine learning friendly. Okay, so this is basically data set. If you study about the data set in Kaggle, you will find that dataset includes 244 instances that are grouped into two regions of Algeria, namely Bajaya region located in the northeast of Algeria, and the Sidi Bel region, okay, Abbas. So these dataset includes two regions. One is Bajaya region, another is Sidi Bel region. Okay, it is a acclamation of both the dataset, and it has got 12 features here. Okay, So here you can see all the features are in numeric column except the classes. We will see how to convert this class into numeric feature in the coming session. So basically up to 124 column you have Bajaya dataset, and after that you have Siddibel dataset region. Okay, so we will clean this dataset and we will train a model from it, so that you will learn what is EDA and how to train a model and how to export a model also. Okay, so this was all about the dataset. So today I'll be using this Google Colab instead of Jupyter Notebook, since many people will not have Anaconda distribution installed. So what you can do is you can make use of Google Colab to train this model. Okay, so let me connect this first. So I have created a notebook called as machine learning with EDA, and this is what, okay, we are going to learn about Algerian forest fire dataset, which includes 244 instances that are regrouped into two regions, that is Bajaya region and Siddibel region. Okay, so there are altogether 12 attributes. Okay, so all the 11 is a feature. Okay, one is a target column, 11 is an independent column, one is a target column. We are going to see which one to choose for that. So once the data, once the notebook is connected to the virtual system, we'll go to files here and you have to upload the file. Okay, go to desktop, then Algerian forest dataset. So my dataset is uploaded to my notebook. So what I will do is, first I will import all the necessary libraries that are required to perform today's exercise. Okay, first is import pandas as PD, import numpy as np, import matplotlib dot pyplot has plt, import cbon has sns. Okay, then for better visualization we'll import matplotlib dot inline. Okay, so this is what we are going to import today. So these are what necessary libraries that are required to do the data analysis today. Okay, so Jupyter Notebook comes up with pre-installed all these Python libraries, so you don't have to install it, pip install. So it comes pre-installed, you can directly make use of it. So first what we are going to do, we are going to read our data set. So the function to read the data set is pd.read -csv. Okay, and you give the data set path. So from here you can copy path. Okay, you can close this now, then control V. Okay, so you can do df. So df is nothing but data frame equal to pd.read csv. Okay, and run this. So what I will do, to see the data set you have to type pd.head. Okay, so this will basically show the data set which was present here. So coming to the next columns, so pd.head will give you first 5 values. Okay, pd.tail will give you last 5 values. Okay, pd.shape will give you the shape of your data set. Okay, pd.shape will give you shape of the data set. pd.columns, okay, will give you column. Okay, should be column. So we'll give you columns that are present: day, month, year, temperature, RH, WS, rain, FFMC, okay, DMC, DC, ISI, BUI, FWI, and classes. So I have given a abbreviation of all these dataset columns. Okay, WS is for speed. Okay, FFMC is fine fuel moisture. So we are talking about forest fire dataset. DMC is duff moisture code. Okay, DC is the drought code. Okay, ISI is initial spread index. Okay, WBI is built up index. FWI is a fire weather index. So basically our target column is this today. Okay, FWI. Our feature columns are, or independent columns are others except FWI. Okay. So before that we will see, okay, some of the things that are involved in pandas. So df.info will give you the data type as well as the null values that are present. See, So D type are all objects, so we have to convert it to the integer. Okay, so we have to make everything integer, float and all. So this cleaning we will be doing. And to find out missing values, you have something called df dot is null. Is null. Okay, is null will give you, okay, the missing data that is present. If you want to see in a better way, you should type sum. Okay, here you can see in day 1 missing values there. Okay, in temperature 2, RH2, WS. So missing values are not as large as in other data set. So you can easily drop these missing values with a simple pandas function itself. You don't have to invoke sklearn and call imputation to fill these missing values. So it will be easy for us to drop because missing values are not that extent. Okay, so we can make use of a simple pandas function to drop the missing values. So before that, as I told you, this data set has got two regions. Basically, one is Bajaya region, another is Siddhibel region. So we will have to categorize both. Okay. So what we'll do, okay, as I told you, up to 122, I think, okay, the region is Bijibel, another is Siddhibel region, okay, Bajaya and Siddhibel region. Let me first segregate into 0 and 1. Okay, I'll create a separate column called as regions where Bajaj region will get 0, Siddhibel regions will get 1, 1, 1. Okay. So for that, what I'll do, df dot ilock, okay, 1 from take rows till 122 rows. Okay, name it as regions. Okay, and make it value as 0. df dot ilock, okay, 122 this thing till from 122 onwards. Okay, and regions itself make it to 1. So okay, there is an error. So I should not have used ilock, I should have used lock. So this is the mistake I did. Okay, so now if I can go, okay, df dot head, if I do, you'll see something called as regions now. Okay, regions and uh, dovetail. So you have columns called as regions now, okay, with 1 and 0. So I have converted Bajaya region to 0, Siddhibel region to 1. Okay, so what I will do now, I will reset the column. Okay, first what I should do, take region. Okay, region. In the region, what you do df region dot has type. Okay, so these are in point, that is in float. I'll convert it to integer. Okay, and run the code. Okay, got an error here. As type integer. Okay, none of the index are in regions I have given. Sorry. Okay, okay, okay. So I have converted my regions to integer. If I do df dot head now, once again, I can see all has been converted to integer. If you want to check its data type, df dot info will give you the information of your data. So I've converted regions to int 64. Okay. So now I will drop the values as I told you. Okay, df dot is null. Okay, dot sum. If I give, okay, I had two missing values in the table. Okay, so what I will do, I will use pandas function to drop all these missing values. So the name of the function is df dot drop na. Okay, and I'm going to reset index. Okay, drop equal to true. So I have dropped all the missing values in my data set. So if I do df dot is null dot sum, once again I should find everything to be in 0. Okay, I think this one mentioned. Uh, df dot to drop any set index equal to some, 1 second. So df dot drop na. Okay. Uh, drop na. Drop some. Okay. So this is what about data cleaning. So now I told you, let me check whether the Siddhi Bell and Bajai region has been segregated or not. df dot ilock. Okay. df dot ilock. Okay. 2222. Okay. So it has got nothing here. Okay. So I'll convert into two-dimensional. Okay, there is nothing in df dot, that means it has been converted to it. Okay, so what I will do is df dot columns will give me columns. Okay, so basically you can see that there are some of the spaces that are present, okay, in the classes and all. What I have to do, I have to make these spaces blank. Okay, what I will do, I will use split function. Okay, df dot columns dot, okay, dot str dot strip, call the strip function, and I'll put it once again to df dot columns. Okay, so now if I do df dot columns, you'll find every now the classes, the spaces that was left has now been filled. Okay, completely. Okay, now there is no problem. So you have to convert these. So these are all in objects. Okay, you have to convert these into integers. So what I will do, I will, I want up to this thing rain, control V. I think everything has been copied. Okay, so, so equal to df, okay, dot hash type, make it to integer, and if I run this, uh, there's a problem to not convert nan. Okay, so I think there is some problem with the column. Once again, df dot drop na, df dot drop na. Why the missing values are not there? Place equal to true. Okay, so in place equal to true was missing. Now that all the missing values have been dropped to 0. Okay, so you get all the, see, this is a live webinar. Okay, so I'm not doing any kind of edit, because if I'm getting a problem or facing a problem, and if you're getting the same thing, okay, you can find solution on the spot itself. Okay, so I can now convert everything to integer. So day 12. So I'll drop this. Anyway, we are going to drop day, year, and column, so no need to. So we are gonna use this itself. Okay, I'm getting some error again. Mass type integer. Mm, invalid literal for integer with base type. Hash type is a function. Okay. One second. Def day equal to df fun day to hash type, make it to integer. Mm, mm, return df equal to with the base 10 day. Okay, because I have to convert it to integer. Okay, df dot info. Think temperature. Okay, df fun temperature dot has type, make it integer. Uh, so I'm getting this error. I will go to Google and check. So whenever you're getting an error, okay, Stack Overflow is your best friend. Okay, find out it. As type. Yeah. Okay, floating point value cannot be converted to int. One second. So this session also involves debugging. Okay. Mm, base 2. Okay, one second. Mm, int 64. 64 is not defined. Mm, expected argument. Okay. It's okay. Okay, I will upload another file. So df1 equal to td dot read csv. I'll copy this part. So df1 dot head. So df dot info. So object type vision is so okay. So what I will do, df dot is null dot sum. Okay, there is no missing value because it is a cleaned data set. Okay, so what I will do, I will segregate the values df dot lock, okay, from first till 122. Okay, name it as region equal to 0 df 122 onwards. Okay, region equal to 1. Oh, sorry, df dot lock it should be. Okay, so let me convert it to integer. Df region equal to df region dot hash type int. Okay, so df equal to df dot drop. Okay, to drop the 20-second ones dot reset index once again. Okay, drop equal to true. Not found in the axis. df1 I should have given. Okay, made a mistake again. df1 df1, sorry. Okay, so I've dropped it. uh, Now df1 dot columns. Okay, so you can see I can use split once again. Df dot columns equal to df dot columns dot str dot strip. I'll strip it apart and put it in the columns once again. So now df, okay, let me now try to convert it. Till ws is fine. So df dot hash type integer. I'm getting errors actually. Uh, so okay, let us figure out it later. Okay. So I'm gonna drop. I don't need day and all. Okay. So what I'll do, day, month, year. Okay. I'll drop it to axis equal to 1. So axis means it is present in the column. That is 1. Okay. So now I have dropped the content. Now I have to convert these classes, right? I have to convert these classes into different types. Okay, so classes not fire should be converted to 0, fire should be converted to 1. So let me catch hold of this classes and see its value count. Okay, so there are different types of classes that is present. Okay, and so what I will do, I will convert everything to 0 and 1. So I will write a function, okay, classes, that is equal to df classes. Okay, so I will write a lambda function here, apply. Okay, lambda will have x. Okay, and 0 if I'll convert it to string. Okay, x dot starts starts with starts with okay, not fire, right? Not fire, else 1. So let me run this code, and if I do value counts of it, so again, so now my data has been converted to 1 and 0. Okay, if I do df, oh, should have done df. So, okay, and df dot head. So all the regions has been converted. I should do it df1. df1 dot head. Okay, so 0. If I do tail, I should find 1 also in my class. Okay, so can you will find some regions to be 1, 0 and all. Okay, not fire is basically 0, with fire is 1. Okay, so now I will do correlation and see df1 dot core. This will basically give you correlation among all of your entire data set. Okay, so think I had dropped this value df1 dot core. Same values are there. df1 dot head. If I do once again, df df1 dot drop. Okay, unnamed, I think this is one column that is there. I'll copy all this. And pass a list here. Access equal to 1, in place equal to true. True should become. My column has been dropped now. df1 dot core. So this will give me correlation of entire feature and target column here. Okay, so if I have to plot this, I can use SNS. Okay, I've already imported SNS dot heat map, and I can pass df1 dot core. So this will give me a heat map of it. There is a parameter called as anode equal to true. So this will give me the values of it. So you have to see here that there is a negative correlation between temperature and relative humidity, temperature and wind speed, okay, temperature and so likewise you can see positive correlation as well as negative correlation. But our objective should be to eliminate these negative and positive correlations. Okay, so that also we can do in the feature selection when it comes. Okay, so coming to EDA once again, okay, what we can do is we can plot this fire and non-fire classes also. Okay, before that we can see distribution. Okay, we can use kernel distribution. There is a function called as plt dot sty style. Okay, dot use. I'll use Seaborn library for this. Then df1.hist bins equal to 50 and figure size is equal to 20 comma 50 plt dot show. Let's run this code. Seaborn is not a style. Seaborn is not a style path. Okay, got some error here. Plt dot style. Mm, okay, no issues. We can do other exploratory data analysis also with this. So I'll give class labels equal to fire and not fire. Okay. So plt dot figure. Okay. So plt dot figure fig size equals 12 comma 7. Then I'll draw a pie chart. Okay. So before that, let me create a percentage equal to df1 in this classes dot value counts. Normalize I will do is equal to true, and I will multiply it with 100. So I'll plot this percentage labels equal to class labels auto pct equal to percentage 1.1f percentage and plt dot title pie chart of classes, then plt dot show. So this is what the classes between fire and unfire. In the data set, around 58% of the data set points fall under the category of fire and 42% fall under the category of not fire. Okay, so this was all about EDA. Okay, in the upcoming session, we will be dealing with how to train a model, how to deploy a model, okay, how to export a model. Then I will even be sharing how to deploy the model on AWS web. Okay, that's it for today. Okay, if you like this session, please hit a like button as usual. Okay, and please like and subscribe to our channel. Please show your support to Technia Solutions. Thank you so much.